We met Hi, I'm Steve. Our speaker this morning is Joel Thomas. He's been teaching science since 2000. He taught for a period of time in a formal classroom setting and then moved outside to direct outdoor school programs. Yay! On the Oregon coast. After nearly 10 years, he started Glen's Gizmos alongside his wife Roxanna, and they have been blessed to travel and to teach together. Recently, they started the Glen's Gizmos Homeschool Hubs, that's a mouthful, in Vancouver, Washington, and Newberg, Oregon. They now serve homeschoolers in the Pacific Northwest and beyond through classes, boat trips, scuba diving, videos, curriculum, and outdoor school programs. So we're excited to hear what you have to share this morning. Joel, tell us what you've got.
Thank you. All right, so yeah, we're excited to be back here sharing again. The last time we were here, we talked about invertebrates and sand dollars, and that was a fun activity. Today we're going to be teaching on sharks and how amazing they are as an apex predator, and how finely tuned their design is as well. And so we're going to be covering a bunch of different stuff about them. We've got one up here. We're actually going to do a little bit of dissecting right here for you on these big screens. And so we'll learn about how God made sharks and how incredible they are. To do that, though, I'm going to jump back over, because I just realized I shut it, to this. Okay. We're going to, except for I shut that down, didn't I? We actually have to have that open. There we go. And bear with us, the technology has been mostly working this morning, as is the case with it often, right? So this is a network we operate. If you ever want to find more about us, you can go to homeschoolhub.org, and you can join this network and look around in there. But we keep a lot of the data that we used to teach from within this network, providing it will work. Which it should, but, you know, technology. Oh, that's interesting. We'll try one more time, then we'll go on to a different plan. I have a plan B for the technology. There we go. Okay. So in Oregon, there are 15 shark species. There's 400 shark species worldwide. So there's a lot of species that have been identified. We have 15 of them. I'm just going to go through the basic ones first so you kind of know what's even here in the area, right? Because it's interesting to know what's around. So there's brown cat sharks. There's smoothhound sharks. It cracks me up because at least 3 of these sharks are named after cats or dogs, right? It seems like. There's spiny dogfish. So now we have cat sharks, hound sharks, and dog sharks, right? There's an angel shark. Some of these are more on the southern part of the Oregon coast, going down towards California. Leopard sharks, soup fin sharks, 7-gill sharks, salmon sharks, which look like small great whites, but they have an extra like notch on the end of their tail that great whites don't have, and they don't get nearly as big. Mako sharks, blue sharks, sleeper sharks, 6-gill sharks, thresher sharks, great white sharks, and basking sharks, right? So those are the 15 types that we have here in Oregon. And of those 15, most are not dangerous to people, right? There's only a few that have even ever really attacked people at all. Even some of the biggest ones, let's look at the 3 biggest. Basking sharks, they're a filter feeder, right? At the surface, they're eating algae, the smallest stuff, the plankton, which the word plankton means wanderer, by the way. So if you encounter phytoplankton, you've got light-loving wanderers, and zooplankton are animal wanderers, right? And so basking sharks are plankton eaters. They're harmless to people, but they're huge. 32 feet is a really big animal. Which if you've never, I see we have some kids out there, maybe some of you adults even. I think I threw a video in here of one of those, actually. We'll see. We just got done with a large marine biology family camp, actually. It's creation-based. Here we go. So this is a basking shark, like what you'd find off the Oregon coast. Huge animals, pretty much as big as a bus, and harmless to people. Sharks get a pretty bad reputation for being the killers, right, and the scary animals of the ocean. Great white sharks, they sort of earn that reputation compared to all the other ones. They are more dangerous than the other ones. There are quite a lot of shark attacks from things like great whites and bull sharks. But even those generally, unless you put yourself in a position or act in a way that you shouldn't, they wouldn't normally attack a person. Thresher sharks are fun. If you've never seen one of those, we'll see if this video will play on here. I think it probably will. So these guys have a super long tail. That's funny, it's playing off one of the projector sound systems up there. These guys have a super long tail, and thresher sharks like this, I wonder if it's going to be in here. I think it will. They come in and they actually whip with their tail to knock the fish out. And that's why they have such a crazy long tail. And we'll see if it'll show us that in here. I think it might in a second. Yeah, here we go. So if you watch that tail flick, wham! And that comes in with such a speed like a whip that it could knock the fish out so that it can grab them, which is amazing. And then the one we're looking at, though, is going to be a dogfish. Let's see if those were the three biggest, right, that we just looked at? Yeah. The next one is a six-gill. We'll talk about that one real quick because those are really fun. They are a kind of silly-looking shark, but they come down from really deep, right? So they're thousands of feet deep, feeding on dead animal carcasses, things that fall to the bottom of the ocean. But they have a unique connection to the Pacific Northwest because one of their main nurseries in the world appears to be the Puget Sound. So they come up from 5,000, 6,000, 7,000 feet down, and then they have their babies in the Puget Sound in the Hood Canal, and then they swim back out. So as far as we understand it, a mother shark, which will be like a 12 to 18-foot animal, will come into the Puget Sound, and then scuba divers encounter them, though they're harmless so far. They could attack and really hurt somebody or kill somebody, but they're really a docile shark compared to all the others. And so they come in, and they are ovoviviparous, so they have egg-laying live birth, right? Is kind of what that almost means. It means that they lay an egg within their own body, and it's separate of the parent, and that it develops attached to a yolk sac, as if it was an egg outside the body, but it's inside. So it is a pregnancy of a sort. And then they have live birth. Once the yolk sac is absorbed all the way, the animal is developed, then the babies come out, and the babies on those are about that long. They're a couple feet long. And the mother has about 80 of them at a time, which is a lot, right? And then the babies grow into young juveniles, right, into young adult sharks. And they'll be about 7 or 8 feet long, and you encounter them in the canal. My wife and I have, they find you. You don't so much find them. We've seen one once. They're pretty uncommon still. And they're bizarre animals to encounter because they have a huge eye. You can see it a little bit in that photo there. In fact, if I do this, whoops, wrong thing to do. Hang on just a second. If I do that, and we jump over here, we might be able to zoom in there and actually see that eye. Whoops, wrong thing. Still not right. Hang on. Okay. We're going to have to jump over to find it here. So we should have just screenshot so we can get in there. So they have this big old eye, and these are considered to be a prehistoric shark, right? Although, as we know, all sharks are prehistoric, because the time frame the world puts on the earth isn't exactly accurate all the time, for sure. And so, but they have that prehistoric crazy look, right? And they have this huge eye. It's like that big, even with like an 8-foot shark, it's a big eye. And they come by and they just stare at you as they go by out of the darkness, right? Or they just sit there and just watch you, because they're really curious about the lights. I've also been curious what they think about scuba divers, because scuba divers often wear exposure suits, like dry suits, that probably limit the electrical senses of a shark. So they probably insulate the diver from electricity so that their electricity in their own muscles isn't going out. So I don't know if a shark only sees like a live face and the rest of a dead body. I don't know what they're thinking when they see a scuba diver in a dry suit. But I think they're very curious about us, because like the one we saw, and we've heard this from lots of divers, they'll come in and suddenly you'll be aware that there's an 8 to 14-foot animal with you, a big shark in the water with you. And then they do a pass by you real close. So in our case, I saw it coming from 40 feet away on the left. It's swimming towards us with this big snaky shark-like motion. These are very fluid swimming sharks. And then it swam right under us. My wife was over here. She was looking that way. And there's no real way to say, hey, look over there real fast, right? And so the first thing she saw, she looked down and she just sees all shark a few feet from her, below her, and swimming by. And then it went out and it did a big circle about 30, 40 feet away right at the end of our flashlights. And then it comes straight back at us again, because they do multiple passes, and each pass is closer because they're curious about you, right? This especially is a really mild-mannered but very curious shark. So they come closer and closer until they're rubbing you like a big kitty cat. Until either you leave, they decide they're done checking you out, or you kind of push them away on the nose so that they'll leave you alone a little bit. Otherwise, they're just very curious animals. So, pretty fun to get to see, though, are big sharks like that. Okay, so I also put on here this little thing here, which will give you an idea of, once I get back to it, of, sizes. So we'll start at the smallest, shall we? So this is done to scale, right? So a brown cat shark to scale relative to each other. So a brown cat shark is 2.2 feet long. The next largest one we have in Oregon is the smoothhound shark, which is 3.3 feet. The spiny dogfish, which is what we're going to dissect today and talk about mostly today, which is 4.3 feet max. Often they're only a couple feet, though. Pacific angel shark, 5 feet. Leopard shark, 6 feet. Soup fin, 6.5. Seven gill, 9.8. Salmon sharks up to 10 feet. I've seen those washed in about 6 feet long. Short fin makos are 12.9. Blue sharks, 13. Sleeper sharks, 14.4. Six gills, 15.7. Thresher sharks, 20 feet. Although, as far as I can tell, I don't know about that measurement. It looks like it counts that whole tail, right? Which makes sense. That would be a super long animal then. Great whites, 21. And basking sharks in at 32. So that gives you an idea. There's quite a bit of range, right, with sharks as well. Okay. Great. Whoop. So let's talk a little bit about the animal in front of us. So we're going to do some learning about the shark I have right up here. We'll put it up on a screen for you so you can see it. There we go. There. Okay, so right here we have a shark that is a spiny dogfish. So does anyone out there have any idea why people called this a spiny dogfish? That doesn't sound like a very good shark name, does it? Anyone have any ideas? I can give you some of the ideas I usually hear when I'm with kids all the time. They think maybe it barks, right? Most fish don't make very much noise. If you can move a swim bladder around and make noise by squeezing air in and out. Sharks don't have a swim bladder, so they're pretty much soundless for the most part. So it isn't noise, it doesn't bark. Some people say, well, it's because it chases catfish or chases its own tail, right? Those aren't the case. Though there are cat sharks and catfish, but it probably would chase them if it could catch them. But that isn't the reason. So dogfish chase and hunt things in a pack. So in the case of fish, we call that a school, right? But in the case of these guys, they hunt things in a pack. We're going to open this up. It will smell a little fishy. Don't worry, the smell will go away as soon as we put this back out of the building. And it smells fishy because sharks are a fish, right? They're full of shark oil or fish oil, especially with their liver. There we go. Grab it by the rostrum, and we're going to pull it right on out of there. Later on, if you'd like to, you can touch this with a glove on, since I know some of you are thinking how much you'd really want to do that. Get rid of that before we make a mess. This shark is probably preserved in Carosafe or formalin. And then the red on it is not blood. When you see that, that's not blood. This shark has had dye injected so we can see veins and arteries better. So the red are going to be the arteries primarily, and the blue or purple are going to be the veins that we'll see in a little bit. If it's been triple injected, we'll see. So let's talk about external anatomy on this animal, because God made an incredible animal here. And a shark is what's called an apex predator, which means it's at the top of the food chain, right, in its environment. And when you're thinking about a predator like this, it's kind of odd to think back to the Bible verses in Scripture that talk about, the world living in more harmony and not really having predation upon each other as organisms and such. And so the best description I've heard of that is kind of to talk about how maybe God put in these pre-planned ways for things to adapt and adjust in the genetics already, right? And if that pre-planning was already in place, that points to an even more amazing creator than if not in place. I mean, the fact that God can put all that stuff into the genes is incredible. We're going to talk more about shark genes in a little bit too. There was a study done on sharks that looked and mapped genes of a few different types of sharks. And one of the things, the study, of course, was being done from an evolutionary perspective where there was a lot of money to help push the study through and such. But they made some interesting discoveries in that as well when it comes to evolution and actually evidence against evolution. And so we'll talk about that as we get into it more too. But to start with, let's talk about the external anatomy and the 5 senses of a shark. So let's see, is there somebody who thinks they can name all 5 senses we have? Maybe one of the kids over here. Yeah. Touch. Scent. Smell. Scent. Hearing. Taste. Eyesight. Yep, seeing, right? So those are our 5 senses. Sharks have been gifted with a 6th sense that we don't have. Does anyone know what that 6th sense is? Yeah. Yeah, they can sense electricity in the water around them. We're going to talk about why that's important in just a little bit. So let's talk about external anatomy. When you're thinking about a shark like this, I want you to think about this shark as if it's a jet plane. Okay, this is a fighter jet. And there's a number of reasons we're going to compare it to a fighter jet. For one, this shark has got a really big motor back here, right? This huge tail, this big caudal fin. And the caudal fin is very strong. It has a unique shape that pushes the shark forward through the water very fast. And if we look inside of here, though it's a little bit mixed up by all of the dye that was put into it, but if we look inside, sorry about your phone, honey. If we look inside of here, this right here is where the vertebra is of the shark, which, by the way, here's an interesting question. Sharks don't have a bony skeleton, right? So are they an invertebrate or a vertebrate? A vertebrate, how come? They still have vertebra, right? They're just cartilage vertebra. You still have cartilage in your body too, like in your nose or your ears that never calcified or never mineralized into bone. And sharks just never have that happen. They stay as a cartilage skeleton. It's very helpful to them because they're very flexible We'll look back at that in just a second. But it means you can take a shark like this, right, and you can just bend it all the way in half without breaking it. I'd like to see any of us be able to do that. I know there's a few crazy people in Cirque du Soleil or somewhere that can do that, but the rest of us, it's not so possible. So right here is the cartilage here of the vertebra. I'm going to push that off to the side so we can look back in there a little bit better. There we go. Right here is the vertebra structure. The top bit up here on the dorsal side, that soft tissue right there at the tip of my tweezers is the spinal cord coming through, right? Soft white tissue. When you think about a shark, you're comparing it to a fighter jet because both are designed for one, right? There's a plan in place that built both of them. Although sharks are infinitely more complex and more amazing than anything any person has ever made. But when you look here at the top and you see that spinal cord, that's like the electrical wiring on a fighter jet. It gets signals back and tells the pilot, the brain, what's going on the aircraft. And it also sends signals and electrical impulses to make the muscles do things, to change and move parts of the body, right? So we've got that. On the bottom here, there are two tubes. One of them is exposed right here. They're right next to each other, though. That little tube right there is the artery with oxygen-rich blood coming from the gills, right? From the heart and gills. And so when you're thinking about a fighter jet as an analogy, that little tube there is where the fuel lines are. Those are bringing the oxygen to run the engine. These huge bunches of muscle back here are the engine. And it's taking away waste, right? So that's incredible design. And when you compare it to a fighter jet, you can see design is really evident in that. You wouldn't ever look at a fighter jet like an F-16 or an F-35 and think, oh, that just happened by chance over millions of years. I don't care how many millions of years. You would never think that. But somehow we think that about sharks, and this is actually far more complex, especially once you start looking closer and closer and closer at the design of the animal. So we have that part there. Another way a shark is like a fighter jet. This shark has no swim bladder. So most fish have a swim bladder up here near the top inside their body. It's a sac of air. When they want to go down, they squish it, right? Or they let a little air out, one of the two, and they drop if they want to hold their position. If they want to go up, they can swim up too, but they can expand that a little bit and it'll make them go up. It helps them control their buoyancy. It's like a BCD, the buoyancy vest that scuba divers wear. It sort of works like that. In the case of a shark, they have no swim bladder whatsoever. So a shark is always sinking in the ocean. That's why you always see sharks swimming on TV, on documentaries and Nature Channel, because they can't stop swimming. As soon as they stop swimming, they sink to the bottom. So an animal like this is like a fighter jet in that way, because if a fighter jet stops flying, it sinks to the bottom, right? It crashes. And a shark would be that too. And a shark has got these big pectoral fins here and all these other fins so that as it's swimming, it can control its position in the water and it doesn't drop, right? All the way to the bottom. For a while, people used to think that sharks had to keep swimming to keep passing oxygen over their gills. And if they stopped swimming, they would suffocate, all the different shark species. But in reality, there's some spiracles up here that are muscular that for many sharks can pump enough water over the gills to keep them going, even if they aren't moving. Excuse me. And there's a few types of sharks that actually live on the bottom on purpose, right? Especially in the reefs, where you have those shallow reefs and the sharks can actually live on the bottom. And then there's rays and skates, which are also cartilage fish, which do live on the bottom the whole time, and they have extra developed spiracles that we'll look at in just a little bit for that plan for them. Okay. We're going to come back to their skin in a little bit. They have very specialized skin. But now let's look at the dorsal fins. So this animal has got two different dorsal fins here. One right here, and one back here. And in the case of a spiny dogfish, they would have actually had a spine here that's been chopped off, or it would have been chopped off. And so they don't have that on anymore. They removed that for vacuum sealing. But they would have had that as a defensive thing. The spine on a dogfish is a defensive piece that sticks up. And it's there so that when a bigger shark, for example, tries to take a bite on them, it stabs them in the roof of the mouth and they spit it out, right? And that spine is actually a tooth. It's got enamel and it's living like a tooth, as well as all the little teeth on their skin that we'll look at under a microscope in a second, and the teeth in their mouth. So this type of shark would have 3 types of teeth. Most sharks have 2. All right, let's talk about those 5 senses. So, eyesight. We'll just start with that one, shall we? Sharks have a pretty good eyesight. I'm going to bring you in nice and close so you don't miss out on all the fun. And we're going to take a look inside of this shark's eyeball. How does that sound? Pretty good? There's a lot of smiles over there with the kids. I don't know about the rest of you. So a shark has actually very well-developed eyes, though they're way out on the sides of its head. Oh, we should talk about that first. So when you see an animal that's a predator, it's unusual to have eyes on the sides of the head way out here. Most predatory animals have eyes up front, more like you and I have, right? That gives you a hint as to what this animal, God made this animal and what it's using, right? When you look at this animal, it has eyes here. That's like a deer or an elk or something else. They have eyes way out here because they don't need to go cross-eyed to judge depth quickly. They aren't relying on eyesight to catch their food. In the case of a deer and elk, they go down to bite the grass that they just looked at, and it's still there, right? It didn't move very fast. In the case of a shark, they use other senses at the last second to get their food. Oh, thank you. Maybe it went to sleep. Just try waking it up and see. Yeah, that's what happened. So, eyes on the sides of the head are somewhat unusual. Here's a little experiment for you. Put your thumb out like this and give it a thumbs up. Stare at your thumb with both eyes. Move it towards your face until it touches your nose. Uh-oh, did you touch that? Oh, we'll find out. Okay, when it's up touching your nose and you're staring at it, you're really cross-eyed, right? Now move it back away from your face. Better, huh? So the closer something is, the more cross-eyed you are. Your brain can do the math, basically, to figure out how far away something is very fast. You learned to do that when you were a little baby grasping at things out of a crib, probably, right? At the little mobile going overhead or somebody's hand coming down, right? For an animal that can't go cross-eyed, they can't judge depth with their eyes. So they're using other senses to be able to judge depth. And sharks, they can't go cross-eyed. In fact, many sharks don't rely on their eyes at all when they go to catch their prey. Their eyes will have a membrane that covers to protect it, or they will actually roll their eyes backward in the head like a great white would do. You're going to have to just untape that. We're going to have to start over with it. Sorry. Okay, so she's going to try to figure that out and get that working again. It's been picky. So eyesight, we're going to come back to that. Let's talk about, let's see, which one will be best next. We can do that one right now. So while we're at it, unless you got it, looked like you almost had it. There it is. Nice job. Thank you. Our adapter apparently has to be in just the right spot to work. And if we breathe on it wrong or look at it backward, it turns off. So we're going to take a look at this shark's eye. So you know how inside of your eye you have a round lens? Some animals with more complex eyes have a round lens. A few of them, like squid and stuff, have like half a round lens. It's like, half a sphere. But this shark has got a round lens that's very much like yours and mine. We cut into it right here. We'll be able to actually get it out and see that little lens. The lens of the eye is multiple layers. It's almost like an onion. And it's going to be kind of cloudy and white more than likely. Once we get it out, we'll see. Because the chemical they put it in often changes how it looks. There we go. Aha! So this right here is the lens of the shark eye. And it is a hard, almost crystalline-like structure. It bends the light because of the changes in density to be able to focus things. It's not at all unlike taking a magnifying glass and moving it in or out or stretching or squishing the magnifying glass a little bit to get something into focus. And then it focuses the light to the back of the eye. So in the case of a shark, this is the lens that does that. And it's an incredible design. It would have nerves on the back edge of the eye that take it in towards the brain, which shark brains look really weird. We'll learn about that in a little bit too. But that lens allows it to focus. So sharks see things at a distance and rely on that to find their prey sometimes, or to watch out for other predators. But sharks don't use that at the last second to catch their food usually. This explains something to me, because I've always thought, I remember when I was a kid, like some of your ages over here where I see a bunch of kids sitting, or about 10, 12, 15 even maybe. I thought, well, okay, so the best defense against sharks, according to the Nature Channel experts, right, however much of experts they are on different things, is to get all your buddies together in your school of fish, stay really close together and swim as a group, right? Which seems like a horrible defense from a human perspective, because you see that big old school of fish, you think you just swim through with your mouth open and gobble them all up all at once like a buffet line, right? But in reality, sharks are using a different sense. They're using their sense of electricity at the end. And so they can't necessarily see those things. We're thinking like humans with our eyes, right? Sharks are thinking a little different. Okay, so we have the lens. There's going to be a lens on either side. Then we have the sense of smell. Have you heard sharks can smell blood in the water miles away? That sort of thing, that they have a great sense of smell. They do. So if we turn it to the ventral side here and we look on the rostrum, we have the nair over here. It's like a nostril that points forward, and the nair here that runs the water back out. So as a shark swims, water is always going in the forward-facing nair and out the backward-facing one, and that happens on either side, so they have two of them. When it goes through those, it passes through constantly, and it passes over these little folds of tissue like an accordion inside. That increases the surface area, so every little bit of blood or chemical in the water is likely to hit a receptor somewhere, right? So that it has a great sense of smell in the water. And some scientists think, or some fishermen, anecdotally, some fishermen believe that there are a couple sharks that are on the scene first if they're in the area. One they say usually shows up first are bull sharks. That may be because instead of keeping their heads under the water, sometimes bull sharks have learned to put their nairs just out of the water where the smell might travel a little faster in a different direction in the wind, right? And then they can follow it down that way. They also say that hammerheads are often first. And one theory on that is the nairs are way out on the ends of the hammer so they can triangulate the position of the odor quicker, which is pretty amazing. So right here, behind this nair, there's going to be a round object about the same size as the eye itself, or the lens of the eye at least. So it'll be about that big right in there. And that is going to be full of folds of tissue that allow it to sense the blood in the water. Oh, look at that. We're already seeing a lot of that stuff coming out. Okay, we'll do this quickly then here first. So, do you see all this clear jelly oozing out? Hang on. There we go. It's oozing out of there, and all this clear jelly, it's on the top of my thumb now. That's pretty interesting looking stuff. That stuff there, that's that clear jelly material, those are from the electrical sensing cells that are all over the body, especially on the head. So if you look, there's all these little pinpricks, little dark pinprick spots, like where hair should be, but there's no little hair sticking out, like a little hair follicle. Those are full of this jelly that senses the electricity those cells do. And there's a whole lot of them here by the eye and on this side of the head, over here. And then there's a whole lot of them over here on this side of the head too. And that allows the shark to use electrical sensing ability to triangulate positions of its prey, right? So, everyone do this with your arm. Let's see those big muscles. Yeah. So when you do that and you flex your muscles, what happens is you're sending an electrical signal from your brain through your spinal cord, out the nerves, all the way out here, and electrocuting this muscle a little bit. It tells it to contract, right? And when you do that, that electrical signal, though it doesn't seem like enough for us to sense because we don't have that ability, God didn't give it to us, A shark has the ability to sense that electricity, especially through salt water, right, or in the water. And so every time a mussel moves in the water, they can sense it, and they can tell where it is and probably about how strong the signal was, right? That means if you're swimming with your buddies, your other fish, in your school, and a shark comes up behind you, your best bet may be to get off to the side and stop moving, because then you aren't shooting off all those electrical signals, while your other buddies keep swimming, right? And the shark chases them down. So anytime a mussel moves, they can sense it. And the more frantic something attempts to get away from them, the more it lights up on their radar so they can find it, which is a crazy thing to think about when you consider it. Oh, this is not working again. There we go. So the more something moves, the more they go after it. Here's an interesting thought for you then. Do you think a shark can sense fear? What do you think? Fear? Okay, so what are some of the things that happen within a body when you're afraid? The heart beats faster, right? You maybe breathe a little faster. There are physical things that change when fear is part of the equation. So, though a shark may not know what it means, I think they can probably sense fear within something, within an organism. They probably can sense the heartbeat. They can probably sense how strong or how fast it's beating. It's possible that sharks can even sense if another animal is pregnant or not, and sense a second heartbeat. I know there's been interesting studies that some people believe dolphins can actually do that, and that they're more protective of other organisms that are pregnant. But it's not proven yet, right? Because it's such an anecdotal thing. But it's interesting. So in the case of a shark, they can probably sense fear in the water. That's why they say if you're around a bunch of sharks, don't make a big commotion at the surface. Don't splash around a lot. Don't move a whole lot. Just sit there and calmly leave the area as best you can, right? Because you aren't sending off all those signals that trigger them. Okay. Let's go back to this. We had that great opportunity with all that jelly coming up, so we had to take a little tangent. But we're going back here to the nares. So I'm going to go ahead and cut right here into the space right behind this nair. I'm going to take a chunk out. We're going to look for the organ that has the ability to sense the blood. See if we find it. There we go. Not quite yet. We're seeing some of the muscles here in the shark. We're seeing some oils in there. I'm going to go up a little bit and cut in there. There it is. Okay. So do you see that browner material right there? That's what we're looking for. Take and cut across that real cleanly here as best we can. Move it to the side. All right. Good. Okay, let's see if we can turn the flash on. Did that do the trick? Oh, we need to go to video for that, sorry. There we go. There, we'll get some light in there. Okay. So right there behind the nair, right in there. That tissue there, do you see all these folds of tissue coming through here? Right in front of my scissors, do you see those folds? Do they show up? Yeah, there they are. Those are the folds that the water has to pass back and forth over repeatedly until it exits through the excurrent nair, the back-facing one. And that's what allows a shark to sense the blood in the water so well, because of all that surface area allows for a lot of sensors, right? A lot of nerves. So it's kind of amazing to get to see that in there. So sharks do have a great sense of smell, and that's why, right there, because that's how God put them together. What about their sense of hearing? Can sharks hear things? Well, they do. They have ears. They aren't very well developed like yours and mine. I don't see a lot of things. There's something that looks like an ear, on a shark. See if we can even find it here. This one, it's not going to be as obvious. Because this, I don't think, looking at it, and the dorsal fin, this is actually a mako or something else. This may not actually be a dogfish. I think this is a similar one. But we're going to look for the spiracle anyway here, if we can find it. I don't see it on that one. It doesn't even show up. But their ears do, so we'll talk about that. Okay, so on some sharks, they have big holes right in front of the gills that are the spiracles. They take the water in and it passes back over the gills on them. This one doesn't show them very clearly. But on dogfish, they have those as well. And sharks raised in skates, they're real developed. They almost look like extra eyes like a frog would have or a crocodile off the top of the head. In the case of this dogfish, though, or this shark here rather, they do actually have ears that are there. See if it says here. Ah, that's why this is not a dogfish. I didn't think so when I was missing the spines. This is an Atlantic sharp-nosed shark that they sent me. Sometimes they'll substitute things in the bags when they don't have what they need. Which is why I'm not finding that where it should be. That makes sense. Most of the other stuff will be there, though. So when you're underwater, if you've been in a swimming pool, you might have noticed that the sound is very loud and echoey, right? Like you hear a sound, it sounds like it's echoing all over. You can't tell where the sound comes from. You have no idea. When a scuba diver's underwater and they hear a boat go over, they have no idea where the boat is. All they can do is look up and see if they see a shadow or something moving over. That's because sound travels way faster underwater than air, because sound travels through materials. The speed is based on the density. So if something is more dense, like a liquid is more dense than a gas usually, then the sound will travel faster through the liquid, right? Same reason that there's that, the stories about people trying to rob trains and stuff, listening to the train tracks, right? Before the train came, so they could hear it from farther away as the sound traveled very fast. So in the case of a shark, they don't have these big ears outside their head to be able to tell distance or direction very well. You can do that here, and I'll prove it to you, okay? So here, we'll do a little experiment. Everyone close your eyes for just a second. Now don't open your eyes. I'm going to go somewhere, I'm going to make a noise. And I want you to point to where I am, and we'll see if you're right. You ready? And I won't make the noise on the microphone, because that won't help you any. How'd you do? Most of you did pretty good, right? So you can do that because God made your ears and your brain in such a way that you can tell how much time passes between when the sound hits one ear than another ear. It's so incredible that you don't even think about it. You don't even know you're doing it, usually. But you can tell. It hits this ear just barely before this ear. That means it's right there, right? And that's incredible. In the case of a shark, they're underwater. They don't really have that ability. And they don't have external ears like that. Instead, they have internal ones, which I'm going to back this off so you can see it. They are located, with my scissors, the ear canals are here and here, right on top of the head. They're tiny, right? We're going to see if we can get you in close enough to actually see them. I think we'll be able to, but it's going to be tight. Oh, we're in slow-mo somehow. We switched. Hold on. I must have knocked it with my finger earlier. There we go. Okay, right there is one little dimple that's one, and right there is another one. Do you see those? Barely there. Those little pinpricks are the ear canal that adjust for pressures and things as they're going up and down. And their ears are sensors that are located deep in the middle of their head, because they don't need them outside where we have ours, right? They don't need the big canals for the sound. Okay, so eyesight, smell, hearing. We already covered electricity a little bit. Taste and touch, right? Those were our last two as we get into it. So, taste. We're going to talk about that when we look inside a shark's mouth a little bit in just a second. Touch. They can feel things all over their body. You're probably familiar with lateral lines. Have you guys heard of that term before on fish? So when you look at a shark like this or most fish, there is a line that runs right through here. It's often indented a little bit. Sometimes it has specks of different color on it, or it is a different color. It's usually located between the light belly and the dark back of the fish, which that's an amazing kind of camouflage, by the way. If you are looking down and you're, say, an eagle looking down into the water, or an osprey trying to catch a fish, and you look down and you see this dark back of the fish, then it's blending in really well with what's below it, right? Because you don't think an animal can camouflage in the open water, but it turns out they really can. If you look up from the bottom, maybe you're a bigger shark looking up and you see the belly of the fish against the white sky, right? The light-colored sky, that's what you get. So it's really a pretty amazing way to stay hidden in the open water. That lateral line system, though, runs right along the side of the shark. In this case, it's this couple little white dots are on it, and it's indented right in here. That's actually a little tube just under the skin with a whole lot of sensors in it that senses when an animal moves. And so if they're schooling together and one fish moves, the other ones can match it before you can even tell that anything happened, right? It's going to take you several milliseconds for your eyes to even ever register that anything happens. Because things can happen actually in the nature, they happen often much faster than we can even see them happen for different things. And in the case of a fish schooling, that's the case. So if you watch fish school, you don't know which fish is the leader of a group because their eyes can't pick up on it fast enough because their lateral lines are so sensitive. And they're so directly connected into the rest of their nerve system. So that lateral line system is right there. Okay, let's look at the mouth, and we'll talk about taste buds too in just a second. So in here, this shark, the sharp-nosed shark, as we've just learned, has a series of very sharp teeth going on. Wonder if we can take a good look at it. There we go. You see those teeth poking out there? Let's take, excuse me, and cut a little bit of that jaw out of there. Now, often you wouldn't be able just to cut through the bone of an animal, right? Because it's going to be too tough. In the case of a shark, we have a decent chance to make it happen if we use small saw-like motions because it's cartilage and not bone. So sharks raised in skates are the cartilage fishes. In the way an evolutionist would describe that is being an animal that predated other bony fishes, right? And then eventually bony fishes became lungfishes, and then lungfishes crawled out on land, and through some miracle that doesn't involve any kind of thinking or higher power or anything else, but would somehow still have to be quite miraculous, they would become, land mammals and things, which is absurd. But in the case of a shark like this, they would say that this animal, which is a cartilage fish, predated the bony fish. But one of the interesting things about some of the genetic studies that are coming out is that land mammals have, in many cases, in some areas, more genes in common with sharks than bony fish do, which creates a bit of a problem, right? Because you would expect sharks to have more in common with fish and fish to have more in common with land animals and mammals. Thank you. And so it's a very odd problem for them to have when they look at it and say it doesn't line up the way we expect. Of course, the studies are being done to try to prove evolution. They aren't being done from an unbiased perspective. They're being done to try to prove evolution. But at least they're presenting the data somewhat accurately and saying maybe we don't understand this part, or they're just trying to ignore that part and hopefully nobody looks at it in the genome, right? Because it doesn't match up with what they think. But some people are looking at it, and I know that ICR has several different write-ups that they've done about this as well, where they're looking at it and saying, sharks, cartilage fish, have more genetic similarity to land animals than fish do, right? Which throws the whole thing out the window as far as how all that evolution must have happened. However, it makes an awful lot of sense when you think about it this way. So we're going to just back up here just a second. There we go. So that painting there was done by a famous painter, right? And if we look back a little bit, that painting there was painted by the same person. You can tell that they're the same painter, the same artist, because of the use of colors, the way that the painting swirls and the textures in it. In some cases with this particular painter, I've been told their use of yellow and stuff is pretty identifiable. And many of you probably already know who painted those paintings, don't you? So who was it? Van Gogh. You know it because you can identify the artist's work. And though the paintings aren't related, so to speak, they're related through a common designer, right? So here's another one. You probably know that one too, don't you? Just by looking at it, because of the way the light works, the detail in it. It's very idealistic in the appearance of it. And you probably have seen it on lots of these, right? And so that's a Kincaid. And again, it's the artist that you're seeing using the same style in multiple places. So the idea that sharks have many of the same genes as land animals, if it's the same designer, should not be a surprise that maybe fish don't. They're trying to cram in the middle some kind of evolutionary lineup, right? It shouldn't be a surprise because it's the same artist who designs both of them, right? The same brilliant mind behind it. It's the same God behind all of it. And so it's a little bit different way to look at it, but if you refuse to believe in the existence of a creator, then you have to find some other way to try to explain it at all cost. So anyway, sharks, though, create a real problem because sharks don't follow the rules, so to speak, right? Hang on a second here. We'll jump back over. Okay, let's look at teeth. This shark here, which I don't know where my phone went to that I had sitting there. Oh, well. Yeah, that one. Shark teeth are unique in that, yeah, sorry, I had it sitting here so I could watch time. Okay, perfect. Shark teeth are unique in that they're extremely sharp. They come in multiple rows and they fold out. So when you look at this sharp-nosed shark, if you look at the teeth, I'll try to keep my glove finger right behind it. You can see there's a row of teeth in the back edge here. Right there, there's actually one sitting there. Then there's a row of teeth here. As I turn it more, there's a row of teeth up front too, at least 3 or 4 rows of teeth, right? That are super sharp. And they use them like saws. When they bite in, they shake their head back and forth and they chop right through bone and everything. And those teeth in rows replace themselves very quickly. So if they break off a tooth up front, the one right behind slides into place like a conveyor belt. So they pretty much immediately have a new tooth on the front line. And then they just grow a new one at the back row. And then they're just ready with these extra teeth in place. I wish we had that. That would be really handy for our dental bill, wouldn't it? Because it's pretty hard to get good dental coverage otherwise. So these teeth are incredible. They're super sharp. And I brought a couple other things here so that you can look at them. One is this. This is from a mako shark. So you can see those teeth. You can even see that there's just a couple rows on makos, like right in here. You see all those? Several rows of teeth as they're growing on the cartilage jaw. And this one is a little replica from a megalodon. I like it because it's big enough you can really see the serrations along each tooth edge. So they really do work like saws. Not only does each tooth like a saw, but along the edge they're like little saws as well when you look up close. And I'm going to save that. I'll save that part for a little bit. We're going to go on ahead and attempt to look inside of the shark's jaw. Knowing this is a sharp-nosed shark, this is becoming a more difficult dissection than I was expecting because they have thicker jaw cartilage. So we'll back you off so you can see. But we're going to go on ahead and we're going to cut from here back into the gills, which that's not There, that's just for my scissors, okay. We're going to attempt to cut through here into the gill with this scissors, and if not that, we'll use a scalpel and go the other way. I'm going to turn it though so I don't get myself. This is a part whenever we do these with kids, we always have to have parents help because it's hard enough with a dogfish, so. These bigger guys are a little bit tougher still. Perfect. Okay, so let's look inside the jaw. You have to be careful because their teeth are so sharp, they'll cut you. The only way I've ever had, we have scissors and scalpels and probes and tweezers and all sorts of stuff that we use with kids. The only time I've ever had a kid get cut during a dissection so far is because they stick their finger in the shark's mouth and try to pry it open with their finger, right? And they don't see the little teeth, but boy, are they sharp. So this shark in here has a few things. The first thing we want to note, though, is this tongue. Their tongue is stuck to the bottom of the mouth like this. Their tongue can't stick out like an ice cream cone, right? And it wouldn't do them any good anyway because their tongue is completely, totally smooth pretty much. Sharks don't really have taste buds on their tongues usually. Sharks' taste buds are located in their throats. So a shark may not even know what it swallowed until it swallows it down its throat a ways, right? What it bit off. And so we have this smooth tongue here. They can use it to swallow, but that's about it. Then behind the tongue, up in here, we have the gills. These are going to be similar to other fish that you've seen. Sometimes they have pretty pronounced gill rakes to keep debris out of their gills too. This one doesn't as much as a dogfish does. But these gills are pretty special too. In fact, when you look at it, do you see how the first bit of the gill is red and the second half is that purplish blue color? This is kind of the difference right here between the veins and arteries of the shark, right? And so, if you look at this, the blood coming in that's run through the body comes through the back edge of the gills, and then it flows up through the center of these very thin tissue tubes to the front edge up here, where it picks up oxygen, and then it flows back into the body. It's super important that it goes that way, because if it, by chance, let's say, happened to just randomly develop the other way, then they'd only be able to get half the oxygen they need at any given time. The reason is because of the kind of the gradient of oxygen in the water. If the oxygen is here at 100%, let's just say, and it's coming with blood here at 0%, if they were going the same way through the blood and the oxygen, then they reach an equilibrium of 50% before they'd exit the gills. They would never be able to put more than that because the blood would have already put, or the water would have already put all the oxygen it could into the blood and reached a balancing point by the time it leaves, right? But because the blood, which is oxygen poor, goes against the flow of the water, which is oxygen rich, it reaches its 10%, 20%, 30%, 50%, but now the 50% full blood is going to encounter increasingly oxygen-rich water at the front edge of the gill still as it's coming through. So it'll still put all the extra oxygen possible into the blood before it leaves because they're flowing opposite of each other. If it was the other way, there'd be no way it would work out, right? Which is pretty amazing bit of design there. And the little things like that, I mean, and in the world of biology, that's actually a physically larger thing. Most of the stuff is so tiny inside cells that you can't even begin to see it. See if we can get this to work again. Hello? Yes, I'm not my wife. There we go. I would be using my phone, except it got run over by cars on a highway. So I don't use it for this anymore. Okay, so we have these gills and these huge gill slits that the water goes back out of. Let's bring you back a little ways, right? So there's the bigger picture of what's happening here. So the water goes through and then out these gill slits. Great. We've looked at the teeth, we've looked at the gills, we've looked for taste buds and didn't find them, which we shouldn't have. I've cut my glove on a shark tooth already. We're doing really well. Okay. Let's check time. Okay, this is a good stopping point for you if you want to do your stuff, and then we'll come back and talk about internal anatomy in the second half.
Wow, this is interesting. Really interesting. Thank you. Okay. So let's take a 20-minute break.
Let's see if you can get it again in just the right spot. Okay, so we talked a little bit about the senses of a shark. We've talked about how taste buds are in the throat, not necessarily in the mouth of a shark. That contributes partially to the, probably that contributes partially to shark attacks. And the reason why a shark will sometimes bite like a surfboard and part of that, and then spit it back out and not finish it, because they can't go up to a surfer and lick the bottom of the surfboard and say, hey, I don't want to eat that, right? Because they don't have the ability to put their tongue out of the mouth and they have no taste buds there, so they actually have to swallow a piece of it to be able to tell. When we're looking inside, we'll actually be able to see the taste buds in the throat in just a second, which will be really good. She's working on getting this thing up and running. If we can get this up and running on this microscope in just a second, we're going to actually show you the shark skin, the teeth in the skin, and the teeth in the mouth up close so you can compare them and look at them. Sharks have really specialized tooth structures. On their skin, they also have teeth. So in their mouth, they have teeth, which are more like what you think of as teeth. On their skin, they have what are called dermal denticles, derm meaning skin and dent meaning having to do with teeth, right? Or placoid scales. That's two different names for the same thing. There we go. Nice. Thank you. You saved the day again. Yeah, that would be nice if it would. We'll try. So far, it's not loving the idea. There we go. Okay. Nope. Okay. No, I don't want to take a selfie. I don't even know how that works. There we go. No? Oh, there you go. There we go. Sometimes I don't understand why electronics work one time and then don't work the next the same way that they just worked. I would have thought it would work the same way every time. Okay, so we chopped off a little bit of this jaw earlier so we can take a look at it. So let's take a look. We'll get it in focus here. I don't know if I like that part of the jaw as much as this other part, though. You know what? We're just going to throw the whole shark under there. How does that sound? Pretty good? Maybe we'll put something on there so it doesn't tip over. Okay. That'll work better. Go down a little. There we go. Thanks for bearing with me as we get this sorted. We'll be able to look at a whole bunch of stuff this way now. There we go. Oh, hey, look at that. You can see all the little holes where the jelly comes out that senses the electricity, all the little ampulovalenzi. There we go. So you can see a few of the teeth coming through right there on the front. There's one that's real prominent, right? So they have those little teeth, and then a shark has specialized tooth structures all over its skin. That's what I want to show you next. So we're going to go on ahead and squish a little bit of this skin down to the side. We'll draw this back up. And we'll take a look at this specialized shark skin that God gave it. Sharks are interesting. Scientists have several reasons to study them. One is their skin itself is unique in that it is covered in small teeth. They have enamel on the outside and living tissue on the inside. When you look in there, you can see that there's some little teeth. We're going to try to get you closer. So that's 20 times. Here we go at 40. See if we can bring that into focus for you. Once we get it, it's really going to be, it's quite a pretty thing to get to see, actually. I wonder if we want to be there or actually on the darker part of the back, maybe. There we go. Yeah, that's better. Try to catch right up in, maybe over here. Trying to get some that are really visible for you really well. There, some of those are pretty good. Okay. Hold on. Now we just got to make it so that I don't hold it, because I'm the one shaking it for you. I could, that's the way I normally do it. Maybe I'll just do that again. Normally I just cut off a bit of it and put it under a microscope, which is probably the way to go about it. Okay, there we go. Okay, so when you're looking at this is actually a whole lot of little scales that all point in reverse. So they're kind of diamond shaped. They point up like that. If you put your 3 fingers together like that, they point up like that, this direction in this case. And I still don't love it. The ones on this sharp-nosed shark don't show up as good as a dogfish. There we go. You can kind of see some there. I'm just going to cut a piece off. It'll be easier. And we'll just throw it under the microscope like normal. There we go. Okay. There, bring you down to it there. This will be way better. Okay, so now you can see all these little tooth structures. They're actually pointing backward like that. They have kind of a triangle shape or diamond shape to them. And those tooth structures that are on there are unique in that they heal very fast. So one of the things scientists aren't quite sure how it works is when a shark gets cut, they heal much faster than most any other organism. And the theory is that that three-dimensional structure slows down how fast bacteria can grow on the surface. So you'd think a smooth surface would be much more sanitary, right? Well, and it is sort of easier maybe to clean it and bleach it off, but if you miss a little bit, the bacteria grows back on it pretty quick, like in a hospital. So some places have experimented with shark skin, fake shark skin surfaces to attempt to retard or slow down bacteria growth and infection. It's one of those amazing things that God built right into the shark that we're just now learning more about. They also all point backwards, so when you feel a shark, you can do it later if you want to with a glove on, you feel them backward, and they're rough like sandpaper, and they've been used as sandpaper in some places of the world. And if you feel them from the nose to the tail, right, then they are smooth, really smooth. And so Olympic swimmers have used shark skin suits for a while, where they use a swimsuit that has that sort of design on it on the outside, so they go just every bit faster through the water is the idea. Just that little bit that they need because it's such a competitive sport. So shark skin is pretty impressive stuff. They're covered in teeth. They often have an extra spine or two around in the case of a spiny dogfish, right? The 2 extra spines that are also teeth, and then teeth in the mouth, which is pretty amazing. There's another thing that's amazing about sharks. Well, but first let's do this. You remember we looked at the gills? Let's look at one of those under a microscope. We'll pull a piece of gill in here. And bring it into focus. I'm going to back us off. This will be 20 times bigger instead of 40. There we go. So this is the gill material here. You can see the blood would come in this end. It would flow through here, and it would leave full of oxygen over here through those little tubes. And they're very thin, sensitive tissue, or very thin tissue rather, I mean, sensitive to things happening to it, not necessarily to touch. But that allows the blood to pick up that oxygen and then spread it throughout the body. On a fish, like a bony fish that lives in the ocean, and a shark too, they have to osmoregulate, right? They have to control the salt. So if you're living in the ocean, you've pretty much got only one thing to drink, right? Salt water. And you're going to have salt trying to get into your body in all sorts of different ways. And you have to keep the salt out of your blood, because too much salt, even in a fish in the ocean, will actually kill the animal. So they have, in a lot of bony fish, special cells on their gills. So every time a fish is flapping those gills and running the oxygen-rich water through and getting oxygen, they're dumping salt out of their blood through the cells in their gills. And that allows them to control the salt in their body. Sharks don't have those special cells in their gills. They do it two other ways, which we'll look about inside. So, okay, without further ado from that, let's take a look back inside the coelom, the body cavity. Oh, but first, you probably want to know if your shark is a boy or a girl that we have here, right? Whenever I do that with middle schoolers, we lose the room right about then, because they weren't thinking about it, but now they want to know. Okay, so this right here is part of the vent. It's like the lower part of the intestine, sort of. It's sort of like that, but not muscular. And it gets sucked when it's vacuum sealed back out of the hole here, which is the vent where they go to the bathroom, right, and mate from. So this is not a reproductive organ. It's just part of the intestine getting sucked backward. If you look at a shark, though, on these fins here, right in here, these pelvic fins, when you look at these, if your shark has an extra thing sticking out here about this far to the end of it, right here, it'd be like, not metallic, but it would look like that on the inside edge of that fin. That is called a clasper. That is what the male would use. There'd be one there and there to inseminate the female. So if your shark is male, it would have a clasper right here. If it's female, like this one is, there's no clasper present on this fin. So we're going to take and we're going to cut from here up to between pectoral fins and learn about the amazing parts inside of this animal. I'm afraid I've pretty much entirely lost my voice after this last week. We ran a family camp with 70-ish people present in Hoodsport, Washington. For this particular program, we rent a small scuba diving resort for a week and go up there, and we live feed and broadcast scuba videos and teach from under the water with audio and video back to the shore live. We do night diving that way. We do teaching on the shore with various things, and we, of course, all of it's from a Christian perspective, honoring God as a creator. And we also have been working with a bunch of teens, so now we have 5 or 6 total teens trained to dive with us and do stuff for us on scuba dives, which has been really nice. And a good opportunity for them to get out and do something together, too. Okay, so we're going to cut to both sides here so we can see what's inside more easily. This shark has significantly more muscle on the edges than a dogfish does. Especially on these front fins, they have much more muscular front fins than a dogfish. You can really feel that in there. Okay, we're going to go to the back here again and cut to both sides just a little bit so we can open up like a book to read it inside. There we go. Lots of muscle there. Okay. On the shark, in the skin on the side, you can see right away veins and arteries right in there. So oxygen-rich vein or arteries coming out, and then you can see some veins running back here with blood back to the heart, right? right in here, the most prominent organ in a shark is the liver, because a shark is a predatory animal. And it's real prominent for a few reasons. You know, if sharks only ate people, that'd be a problem, because people are not the right nutrition for a shark. Sharks require a lot of fats, right? Proteins, blubber, those kinds of things. And if they don't have it, they won't be able to survive for a number of reasons. Number one, they need a lot of those oils and things to live off themselves nutritionally and everything, but they also have this huge liver. There's a lobe here, there's a middle lobe in the center, which we'll get in just a second, and then there's another side lobe here. So of these liver lobes, there's the little middle lobe right there. Of these liver lobes, these are tissue that are full of fats and oils. And as you probably know, oil floats on top of water, right? Especially on top of salt water, which is even more dense than fresh water. And a shark's liver stores that oil. Do you remember sharks don't have a swim bladder? We talked about that. If they didn't have a overdeveloped liver with a lot of extra oil and fish oil being stored, they would sink to the bottom like a rock. Instead, they float fairly neutral most of the time, or don't float, but they can sit fairly neutral in the water, so they don't sink so fast. So the liver helps with that. The liver also filters their blood. This may matter for a few reasons. One of them is sharks are an animal that science is interested in because sharks have a really low rate of cancer. They almost never get cancer, and nobody's quite sure why. So that's something that is really curious to people for a number of reasons, especially because if we can figure out why sharks don't get cancer, maybe we can help keep people from getting it, right? So sharks don't really get cancer very often. It may be because of these huge organs that help filter blood and such. Maybe they have something to play in it. I don't know. But also, these huge liver lobes do filter blood, and they control hormones and balance things within the body like your liver and mine does. And that's especially important to a shark because do you remember I told you sharks don't have the special cells on their gills that get rid of salt into the ocean to osmoregulate and control their blood? So one of the ways that a shark controls how much salt is dissolved in its blood is by keeping toxic levels of urea, of waste in their blood. So of all sorts of wastes. So if they can keep so much other stuff dissolved in their blood that the salt has nowhere to dissolve into the blood as easily, then they won't pick up as much salt through their digestive system and through their skin. So by keeping toxic blood, they can keep more of the salt out because there just isn't as much room for the salt to come in. So if you and I had shark blood in our bodies, we would not stand a chance, not just because of shark blood, but because there's way too many toxins inside of shark blood there all the time, too much waste built up. And that liver may be one of the ways that they are able to filter that blood and not go over that limit because they push it right up to the limit, right? Okay, they do have a gland back here. Let's go to the back. That's used for this too. So this little gland right here above my fingers, you see that little gland? That dumps the salt out the vent. This is a salt gland. It collects salt from the blood and body and dumps it back out their vent. So they do have that, which also assists in getting rid of salt. Those two things, toxic blood and a salt gland, help them out. All right, so we're going to take a look at this middle lobe here, see if we can find where it would drop down. Should be right there. It's not full, so it's not real obvious, but it should be there. Yep. Okay, right in here on the underside of the liver, it changes right in here to something that looks a little bit different, like a little sac at the tip of my thumb, like a little plastic sac or something right in there. That's where the gallbladder is. So it's going to collect the bile there that's used to digest the fatty tissues, proteins and fats, right? And then it helps by passing that through tubes here that are over my finger right now, which are the bile ducts. It passes it down here and connects it here where here through the bile duct on top of my finger to here, which is the start of the intestine, right? I'm going to back off so you get perspective better. So gallbladder's in here on the bottom side of the liver, passes through a bile duct in here, drops it into the intestine down here, right? to digest fatty things. All right. This shark also has its stomach, so let's go look at that. We're going to go on ahead and remove a little bit of this so we can see better. So there goes one liver lobe. Sorry, liver lobe. It's okay, I don't think it minds anymore. There's another part. Okay. Oh. This shark is pregnant. Yeah, on one side. Nope, on both sides. Okay, so this right here is the stomach coming through here. And the stomach of the shark, you can see there's quite a few blood vessels here already running. And then it does a J-shaped thing down here at the bottom. And it should have, it does. Good. Okay. So the stomach comes down through here. Let's cut it open and see what it ate last, shall we? Why not? So a shark is eating little fish, maybe little bits of herring or something else. They might be eating little shrimp. Sometimes you find little shrimp and shrimp eyes and stuff like that in your shark. Sometimes you find nothing at all. There we go. So these folds of tissue are what allow the stomach to expand and contract, right? You have similar folds in your stomach. If a stomach didn't have these folds, then you'd eat your big Thanksgiving meal and your stomach would inside your body, right? Which would be a major problem real fast. So it has all those folds that allow it to expand and contract. If we move up here, this is the entrance to the stomach. You can see a somewhat muscular area right there. If we push past that, and we go a little bit farther, oh, no, we're still in it. This stomach feels like it was vacuum sealed upward a little bit more than we want. Let me look and see in here if we can catch them. I'm not sure if we're going to be able to get to them. Taste buds tend to be up in the back in here. We'll have to come back to them and see if we can find them in a little bit. But this right here is where the stomach starts, runs down through here. It does a J shape here, which is where the intestine starts. Right in there is the intestine. And at the bottom of the stomach, there is a gray-shaped organ here. You can see it spread out. On other sharks, that can be a triangular-shaped organ. That's a spleen. And in the case of your body, does somebody know what a spleen does for the human body? Why did God give us a spleen? What was that? It can store blood cells. Well, not, what's that? It can clean and filter out the blood, right, and damage stuff. Which type of blood cells does the spleen make in your body? White blood cells, right? So it's part of your immune system. It's producing white blood cells. Where are the red blood cells in a human body mostly made, as far as we know? Do you know? The bone marrow. Okay, a lot of people don't know that. They think other places. And well, there is some evidence that maybe some red blood cells are made in places like your lungs or somewhere else, maybe minimally. Most of them seem to come from our bone marrow. In the case of a shark, do sharks have bones? So sharks don't have bone marrow. So all of their blood cells have to be made in their spleen probably, right? So they have the spleen here that does all of that work for them and keeps them healthy. You're fiddling with that, it's off here also, which may be all it is, unless it died. I compressed the turn-off button with the clip, I guess, or something. Okay, thanks. So the spleen makes the blood, right, for a shark. Now there is another organ off to the side that we'll look at in just a second as soon as we get our visual back. And this other organ is the one that's going to make insulin. So what organ would that be? Pancreas, yes. So we're going to look at that too in just a second, which is going to make the insulin to control blood sugar. Hey, there we go. Nice job. Okay, so looking over here, coming in at the top and edge of the intestine, you can see an organ right here above my fingers that's long and thin, and it has this lighter look to it, right? So the spleen is over here. It's dark colored. Let's go closer. There we go. It's dark colored. The pancreas is over here, and it's got this lighter color to it. And so that's the organ that makes insulin for us. All right, looking down here into the intestine, which this is the intestine from here to here, we're going to take a look inside and see what we find. Lots of extra folds of tissue in there. Some sharks even have what's called a spiral valve intestine. So this one has got a lot of folds of tissue to help absorb nutrients. Do you see all those extra folds and twists in there? Some sharks, like dogfish, which this is a sharp nose, don't just have all these extra folds in there to capture nutrients, but they actually have what's called a spiral valve intestine. So if the intestine is only this big of an organism, from here to here, that's not very big, right? And so the food would go in and it would leave the body, right, before anything could be absorbed nutritionally from it. Wouldn't have enough time. In the case of a shark, in this case, they have a lot of extra folds in here. In the case of a dogfish, they actually have a spiral valve intestine, which means the food goes in and then it runs around like a spiral staircase or one of those spiral slides on the playground before it leaves the body. So it doesn't just go in and out. It goes in and then around and around, 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 out. Right? So it goes a long ways instead of just the short little distance. And that allows it to survive. And God sure knew what he was doing when he had him do that, because otherwise there'd be no way that that would work out. Okay, behind all of that digestive stuff we just looked at, we're going to pull the connective tissue out of the way. There are a couple fun things there, but let's look clear to the back of the shark first. I'm going to clear back in here. Do you see those? Oh, we're not connected yet? Hang on, we're fixing it again. We're going to look at where the kidneys are, is our next stop. So your kidneys look like bean-shaped things, or rather beans look like kidneys, one of the two, right? I'm not sure which came first, the kidneys or the kidney beans, as far as naming. But in any case, your kidneys look quite a bit different than a shark's kidneys, but they serve a similar purpose. So the shark on either side at the back, this is, hang on, for perspective. We've dug through everything. We're now along sides on the back of the spine of the shark, okay? Right in here. So on either side of that shark's vertebra and spine, we have this dark tissue right here and some dark tissue on the other side of it right here. Those are two long kidneys shaped like pencils built right into the back of the shark alongside the spine. And so they're collecting the waste from the blood and dumping it out the vent, right? Pretty much like what yours do in a lot of ways. Okay, now we're going to take a look at reproduction of a shark. So we've established right off the bat that this is a female shark because we looked at the lack of claspers, right, on the pelvic fins. So now we're going to look at what's going on in here. Down either side of the shark, there is a tube. Do you see this tube thing right there? Real thin tissue. On the other side, there's one here. Thin tissue, but more full of something, right? These are almost like the womb of the shark, if they had that. So they're sacs down each side that the eggs are laid into, because a shark is ovoviviparous, which means oval or egg, viviparous, viva, live, viparous, live birth, right? So they lay the eggs inside those tubes on the sides, and then they have a pregnancy period, and then the baby sharks are born once they're developed all the way. In the case of some sharks, like a spiny dogfish, which this one is not, but it's a similar shark, that pregnancy is a very long pregnancy. So an animal like an elephant or a whale has about a 2-year pregnancy, right? A little less. In the case of a spiny dogfish, which is a shark that only gets this big, mind you, a few feet, right? Maybe 5 feet, 4 feet. That animal has a 2+ year pregnancy, depending on which part of the planet it's on and how cold the water is, because they're an exotherm, so they aren't warm-blooded. Their development and metabolism is directly affected by the water temperature around them. And these right here, let's get you down to the side so you can see them better. Once we adjust everything so you don't get seasick on us. These are the eggs of a dogfish or of a shark that are laid. You see that one on the left there? Right in there? So these are the eggs that are laid within the animal's body. They're small, they develop into these larger eggs, and they're fertilized and they're growing, right? And they become the yolk sac as well next to it, as you'll see in just a second. That 2-year pregnancy is super long, especially in cold areas, 2 or more years. As they develop, they hatch, so to speak, right, before they're born, or they develop into these guys. This right here is the yolk sac. You know what? I have a glove on. Let's just take a look. So this right here is the yolk sac that developed. This would be the umbilical cord connecting to the mother, except for there's not a mother connected. There's a yolk, right? Because it's ovoviviparous. And then this right here is the young shark that's growing inside. So sharks will then absorb all of that extra nutrition, and then they'll be born once they're ready, after that 2-year period. This shark even has the spines, little nubs of spines in front of the fins. Do you see that little spine? Because this is a spiny dogfish, so it has its little spines starting to grow. So this is an ovoviviparous animal. Some sharks raising skates are not that way. Some of them are actual egg-laying animals. And their eggs don't look like what you might think of as animal eggs. I'll show you an example right here. Have you guys ever found one of these on the beach? Yeah. So this is what's called a mermaid's purse. It is the egg case of a shark, ray, or skate. In this case, a big skate that can be found on our beaches. They wash in. And inside of there would be 1 to 3 baby sharks, rays, or skates developing. Like this, but instead of developing inside the mother, they are growing inside of this egg case. This egg case gets attached to the bottom of the ocean, to a rock or something else right here, and then it washes around in the water like this for anywhere from like 2 to 7 years. And after that period of time, they hatch out and they start their life outside of this protective case. It looks and feels like seaweed, so often you don't realize what you've got when you pick it up. When they're found on the beach as a fun thing, they've washed in, they aren't going to survive anyway because they're no longer attached, right? But you can pick them up and you can get a bright flashlight and candle them like a chicken egg and watch the baby animals in there swimming around, which is pretty fun to get to see. I did that as a kid when I was 4th, 5th grade. I brought it home and I thought, this is fantastic. I'm going to hatch out baby sharks or something, right? Thought, this is the best thing ever. So I went home. I took an old refrigerated drinking fountain we got from George Fox College at the time when my father worked there that they threw away. And I repiped the thing to run it so I could control the temperature and cool an aquarium space to have an incubator for them. And I ran it through there. Luckily, they weren't invertebrates. Otherwise, I would have killed them with copper poisoning right away. And I let it sit there for months. And then I thought after a few months of watching them that maybe I should do a little bit of research about what I was doing. And so I did a little bit of research and realized I was going to have to sit there for 5 or 6 years and keep this thing alive and temperature controlled and everything else. And the likelihood of that didn't seem very high because if I was in 5th grade, I did the math, 5, 6, 7th, 6th, 8th, 9th, 10th. Like, they aren't going to be done until I'm at least in high school, maybe college. And I decided that there was no way that was going to happen. And so They gave up on the project and released them and hoped for the best by dumping them back into the ocean. There we go. Anyway, so that's a mermaid's purse. I also have one up here that is actually, they've hatched out of, if you want to see it. So there's a crack down the middle where they've come out of. And these ones would be out and about, living somewhere probably as big skates. So that's fun to see. So we've got the babies here as well. They're these guys here with their yolk on them that you can check out later when you come on up. Okay. Drop those off to the side. So, now that we've looked at that, let's see what's inside and what this shark looks like inside of these to see what these, because this shark is pregnant. The first time we ever dissected a shark that had the babies in it and was pregnant, we didn't know what we were getting into. I'd never dissected sharks. It was years and years ago. And we started into it, and myself and all the kids in the room had pretty well convinced ourselves the shark had some sort of horrible cancer because all the organs were misshapen and everything, because pregnancy is pretty hard on a body as far as pushing things around and holding things in all the wrong places and everything, right? So we'll cut that and see what we got. There's his little face. There should be a yolk sac, unless it's very close to being born. There is an umbilical cord, so to speak, that's connecting it to a yolk sac somewhere in there. There's a little sharp-nosed shark. Oh, the yolk sac is mostly fallen apart. It would have been right there. You can see the start of it. So probably the storage and the chemicals and everything, the yolk sac just is not survived intact as well. But there it is right there. Boy, you can see why you call them sharp-nosed sharks when they're little, can't you? Pretty fun to see. Okay, so we've got one there. This shark has at least two. Again, it's not developed there. But there's a second one right there. That probably means that there's two down each side, so there's probably four total inside of the shark. Well, sometimes they're uneven. This one looks to be way less developed. So I wonder if it's possible that this particular shark develops them on different times or different speeds in its body. Oh yeah, this is totally undeveloped compared to that other one. Look at the difference in development. That's it right there between my fingers. If that's it, it's pretty much unidentifiable. But something was starting to grow there. Excuse me. Okay, so we've got two out of the one side, and the other ones are not nearly as developed to even be findable, it looks like. We're going to now take a look at who wanted to see the heart? Yeah, that's what I thought. Okay, we're going to take a look at the heart in here. So anytime you're talking about the design of an organism, a designer who's intelligent, like God is, would place the heart near whatever organs get the oxygen so you get the best blood flow and the highest pressure there, right? So in our case, our heart is located between our lungs, and it can pump with really good blood flow to our lungs, right? And then back through the body. And our heart is unique anyway, because our heart has 4 chambers, and fish hearts, like a shark heart, only have 2 chambers. Many reptile hearts have 3 chambers, but they're sort of only like 2.5 chambers because one of the chambers isn't really developed and sometimes has a little hole to one of the other chambers on a reptile. But a fish heart has 2. It's going to be located then, if these are the gills right here, and over here, the heart's going to be right in here to give it the best oxygen flow, or the best blood flow. So we'll take a look, see what we find. There we go. So right there is the shark's heart. This part on the left, I think it's the left for you too, yeah, it flipped it correctly. Let's see about getting you in a little closer. This part on the left that's muscular and stiffer is the ventricle. So that's the muscle part that's going to pump the blood back through the body. The part on the right that's dark colored, and right there next to my thumb, that's the atrium. It's the waiting room. It's soft, like a plastic sack. So in a shark, the blood goes from the body, then it goes to the atrium, where it gets squished over into the ventricle. So it collects the blood in the atrium, squishes it over into the ventricle. The ventricle pumps and shoves it to the gills, and then back to the body, right? So a shark goes body, atrium, ventricle, gills, body, atrium, ventricle, gills, body. That's different than your heart and my heart, which has 4 chambers. Your heart and my heart have kind of 2 halves to it, right? So it goes body, atrium, ventricle, lungs, atrium, ventricle, body, right, in our heart. Because we need the extra blood flow, the extra blood pressure. A shark doesn't really sit up straight very fast very often, right, in the air. So they don't have the problem of passing out if they stand up too quickly. And they're floating pretty neutral in the water all the time. So they don't need as much blood pressure as you and I would have. So God didn't give them that. He gave them a heart that does exactly what it needs to for their purpose. So they have that atrium, ventricle, gills, body design there. Let's pull that out of there, shall we? Yeah. Half of us were thinking it. I'm just glad you said it. The other half of us probably aren't sure, but... So there's the full ventricle coming out there. I'm going to try to get the atrium attached to it too and see how we do. Looks like there's something connecting right there that we haven't got yet. Okay. So this is the shark heart. Here's the atrium, the ventricle, and this is the tube that connects the heart to pump the blood back into the shark, right? Right there. Pretty neat to get to see it. Later on, if you want to, we'll give you a chance to come up and actually feel some things with gloves on, if you want to do that. You could even get a picture of holding a shark heart, so you have proof of it forever. Okay. How about the brain? You want to see the brain before we're done? So a shark has a brain that's kind of different than yours and mine. You know, humans, well, we have many similarities because of a common designer to animals. We certainly are set apart from them and different than animals because we're made in God's image and made in a special, unique way where we have thinking and many other abilities that animals don't have the same way. But in the case of a shark, they have a brain that has a huge amount of their brain is devoted to sensory input and instinct, right? So our brain has this huge brain where a lot of it is devoted to thinking and higher functioning. Very unique to humans, right? In the case of a shark, they have a little bit of brain that's devoted to that, like the size of a pea. And then the rest of this alien-shaped brain that stretches out long, connecting to all the different organs or sensory organs in the body. It's going to be up here. So you remember how the heart was between and close to the organs that get the oxygen? In this case, we're going to look for A shark, who is a predatory animal, is going to have a brain near where all the sensors are on the front end of the animal because it is committed to moving forward and catching prey, right? And the distance you have, because it's an electrical signal being sent from sensors to the brain, the distance you have to the brain matters, because if the brain's at the tail, it'll take it that much longer for the signal to get to the brain to make a decision and send back a reaction, right? So it needs to be right in the middle of wherever the best spot is. So in the case of this shark, we're going to look up here, right between the eyes in this space to find the brain. We're going to have to cut through a pretty significant cartilage skull, because this is a pretty big sharp-nosed shark, to be able to find the brain. Sorry, we'll bounce you around just a little bit, but we'll get there. And the back end of it is going to be connected into the spinal cord, which I think is going to be right in there. Okay. Turn that. Oh, we're losing it again. You may have to save me there. This will take a second to get done anyway.
It thinks you're driving.
Oh, it thinks I'm driving. Technology is very helpful. I'm wiggling, so I'm driving, I guess. Yeah. Okay, there we go. We're going to need to get right into there. You can just move that out of the way while you work on it if you need. Oh, you got it. You're going to hold it so it doesn't think I'm driving anymore? Now, unfortunately, the cartilage, though it can be cut through, is still quite tough stuff. So on sharks, you have to use a lot of thin or small saw-like motions. If you try to do any large cutting motions, that's a surefire way to cut yourself. Every time. We cut right across the top of the eye, right over the top of the rostrum. I'm going to peel up the top of the skull and all the muscle associated with it. And as we do that, we'll continue to check to see what we're doing. Right in here, thank you for holding that. Light. If you want to, sure. You can fit in there a lot better than I can. Maybe not. There you go, thank you. Okay, that'll get us some light in there. So right here behind the eye, do you see, let me get the tweezers. There's the eye. Do you see this material right here? That's some of the muscles that move the eye around. And then right below that, down in here, there's going to be some soft white material. That one may also be part of the muscle. That's going to be the nerve coming off the eye. We may not quite be there. I thought we were already there, but we aren't quite. Oh, there's the rest of the skull. We didn't quite get into it all the way. It's a pretty substantial cartilage skull. All right, now we're getting there. Now, of course, the brain is protected inside of a skull because it's very soft tissue. So we have to be we have to be abrasive with it, but we have to still try and protect it at the same time. Otherwise, we won't have much to see. Okay. There we go. There. So this right here is nerve tissue. It's very soft. You can see all the blood vessels going to it to feed it. This part up here is committed to connecting to the nose, the nares. You can see a nerve heading out right here. Do you see that nerve going? That's going out for the sense of smell, to connect to those circular organs that we looked at earlier down there. and it would go out this way and connect into the back of them right there. In fact, this is the exact one that we cut, so that's the cut surface of it on the other side right there that I just pulled out. So we just pulled that out of right in there. That went for the nares. Then back in here, if it'll show up, I may have already thrashed it too much for it to really show up. There'll be one that connects in here to the eye. And then, do you see this section right? Back us back out again. Do you see this section right in here between my tweezers? That section is the part that's committed to thinking, right in here. The rest of the brain is all collecting information and responding with instincts. There's also a lot of the brain right back in here that is connected to the spinal cord, which also does a lot of stuff with instinct. So we've got a little bit of the brain right here for thinking, and then most of the brain for instinct and impulse, right? So it's pretty neat stuff there. Cool. Okay, so I'm going to chop the rest of that off so you can look at it in a little bit. You could even feel that with your finger with a glove on, if you're feeling like doing that, because it's pretty neat to see it. Okay, how are we doing on time? Oh, I put it back in my own pocket. About there. Is it a good time to do questions, or what do you want to do next? Question and answer? Sure. Let's do it.